In this video, we'll be looking at matrix 001, which is the introduction to matrix. The plural word for matrix is matrices. Then we want to look at an example. But before we do that, let's tell you what matrix is. Well, matrix is simply a mathematical structure that contains numeric values or information, usually enclosed in a bracket or a rectangle. I take that again. Matrix is a mathematical structure, okay, that contains numeric information, usually enclosed in a bracket or rectangle. So we can have matrix A, matrix B, matrix C, or D, any one of those. Let's start with matrix A. Let's say we have a matrix that has 2, that has 3, that has 4, that has 5. We have the one that has 3, 4, 2, and 1. Now, if you look at this matrix, you'll find numbers enclosed in a rectangle or in a bracket. Now, the first aspect of this matrix, this is called the row. This is called the row of the matrix. Now, this aspect of the matrix is called the column of the matrix. For you to know the size of the matrix, you need to multiply the row by the column. I take that again. To know the size of the matrix, multiply the row by the column. So the size of this matrix, the size of the matrix is simply the row times by the column. The row times by the column. Now, how many rows do we have in this matrix? We have the first row, the second row. How many columns do we have in this matrix? We have column 1, we have column 2, column 3, column 4. So the size of this matrix is simply A is, this is 2 by 4 matrix. So that's how to find the size of the matrix, the elements or the numeric information inside an enclosed bracket or matrix. Now, what is to find the position of elements? To find the position of elements in matrix, you need to know that you will use the formula Aij. Now, where I is the row and J is the column. All right, now let's say we have a matrix, matrix B. And matrix B has 3, 4, 2, 1, 2, 4, 5, 6, 7, 3, 4, 7. Now, this is the matrix. Let's turn this to 8. All right, matrix B has this. And you are asked to find the size, find A, the size of the matrix, and then find B, the position of A to 3. All right. Now, what do they mean by that? Now, to find the position of a matrix, you need to know, or let me find the size first, then we'll go to the position. For the size, we have how many rows? 1, 2, 3. For the column, we have how many columns? 1, 2, 3, 4. So for the size of this matrix, A, the size of the matrix is B is 3 times 4. 3 by 4 matrix. But to find the position, that is B, to find the position A to 3, what do? We need to understand that matrix, the first matrix here, which is matrix B, because this is supposed to be B, all right? B to 3. If it's here where we are using A, it will become A to 3 because the matrix we are dealing with is B. So it's B to 3. All right. So if we have this, this will become B. Over here, we have B1, then we have B1, then we have B11, B12, B11, B12, B13, all right, B14. All right, so that's what we have. Now, how do I get this? I looked at these as B1. Then I looked at these as B2. I looked at these as B3. Don't worry, you will understand. And after the 2, I will still have all of the row here will be called B2. All of the row here will be called B2, B2. Just as all of the row here is called B1. And here is B3, and here is B3, and here is what? B3. Now, you need to now put the number that follows after. Now, you see that we have 1, we have 2, we have 3, we have 4. We have 1, we have 2, we have 3, and then we have 4. Now, we are asked to find position B23. See? Position what? B23. I could have used A if the matrix is matrix A. All right? Understand why I changed it to B23. Now, to find the B23, I need to know that this is where my B2 is. So I'll go to B2, and I'm going to B2. This is B21, B22. So this is B23. And B23 is simply 6. The number there is 6. So this is how to find the size of the matrix and the position of matrix. I need my duster now. All right, so let's clean up the board. Let's look at types of matrix. What are the types of matrix that we have? In fact, we have the types of matrix. We have the zero matrix. The zero matrix is the matrix where the O entry is 0. In zero matrix, the O entries of that matrix, the entire entries of that matrix is 0. For instance, we have, let's say we have matrix C, which is equals to 0, 0, 0, 0. Of course, this is a 2 by 2 matrix. We can have D, which is equals to 0, 0, 0, 0, 0, 0, 0, 0, 0. Of course, this is 3 by 3 matrix. Then we have the square matrix. For the square matrix, the column and the row is the same. The number of row and the number of column is the same. Let me show you what I mean. We can have matrix A, which is equals to 2, 3, 4, 5. We can have matrix B, which is equals to 3, 2, 1, 2, 1, 3, and 4, 5, 6. Now, this is 3 by 3, B is 3 by 3, and then A is 2 by 2. Understand that the row and the column is the same thing. It is known as square matrix. Then we have the next one, non-square matrix. For non-square matrix, the row and the column is not the same thing. For instance, we can have A is matrix 2, 3, 4, 5, 1, 2, 3, 4. Now you see that we have 2 columns, 1, 2, and we have 1, 2, 3, 4, 4 rows. So A is 2 by 4 matrix. When the row and the column is not the same thing, it's known as non-square matrix. So this is non-square matrix. All right, so we have the next one is identical matrix. For the identical matrix, it is denoted with the letter I. It's denoted with the letter I. All right, so we can have the I 2 by 2 identical matrix, and we can also have the 3 by 3 identical matrix. And some of the examiners, they believe you should know how to write the 2 by 2 identical matrix and the 3 by 3 identical matrix. This is the most used identical matrix in solving matrix problem. I'll give you a problem after this scenario or explanation. Now, the 2 by 2 identical matrix is equals to, you can just simply write a 1 here, and put the other entries to be 0. So this is 2 by 2 identical matrix. For the 3 by 3 identical matrix, it's not hard to write. You can just write 1 in the first first row, 1 in the second row and the second column, and 1 in the last row, the third row, and the last column. So if I have 1 here, 1 here, 1 here. Now I'm going to put all my entries to be 0, remaining 1 here, 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 0. So this is 3 by 3 identical matrix. This is 2 by 2 identical matrix. Let's do some operations of matrix. Now, the operation of matrix, we have so many of those. We have addition and subtraction of matrix. We have multiplication of matrix. Multiplication of matrix is divided into 2. We have multiplication of matrix by numbers. We have multiplication of matrix by matrix. We even have multiplication of non-square matrix. So for that multiplication of matrix, we'll have a separate video for that. Now we are dealing with, we're going to do some little multiplication anyway, just 1 or 2. Or any of those. Now, but we have addition and subtraction of matrix, and then we have multiplication of matrix, which can be multiplication of matrix by matrix, multiplication of matrix by numbers, multiplication of non-square matrix. That's multiplication of matrix by matrix. Meanwhile, we have the inverse matrix, we have determinants matrix, we have the Cramer's rule, and a lot of those. Now, let's start with addition and subtraction of matrix. Simple ones. Now we have that if A is equals to 2, 3, 4, 1, and matrix B is equals to 3, 1, 2, 4, and you're asked to find the value of A minus B, then of B minus A, and then of C, A plus B, and then of D, B plus A. I think some of those will give you the same answer, but like this one might likely give you back the same answer, but this one might not likely give you back the same answer. Now let's do it. Let's find the first one. The first one says A minus B. All right, what's A minus B? A is matrix 2, 4, 3, 1, minus B, matrix 3, 2, 1, 4. 2 minus 3, that will give me a minus 1. All right, 3 minus 1, that will give me 2. 4 minus 2, that will give me 2. 1 minus 4, that will give me minus 3. So this is the answer for the part A. Now for the part B, I need to do again B minus A. For the B minus A, I know that matrix B is 3, 2, 1, 4, and then matrix A is 2, 3, 4, 1. It's very easy. Subtract the first row and the first column from the first row and the first column at the other side. Subtract just column by column, row by row. All right, now let's go to the answer. 3 minus 2, that'll give me 1. 1 minus 3, that will give me minus 2. All right, now 2 minus 4, that will give me a minus 2. 4 minus 1, that will give me 3. All right, so this is the answer for B minus A. And let's go to the last one, A plus B. For A plus B, I can write my A plus B. Can I write my matrix A? Matrix A is 2, 4, 3, 1, and matrix B is 3, 2, 1, 4. Now 2 plus 3, that will give me 5. 4 plus 2, that will give me 6. 3 plus 1, that will give me 4. 1 plus 3, 1 plus 4, that will give me 5. So this is the final answer. I hope you get the pattern and the way we solve this. It's very easy. This is the most easiest concept. All right, let's say you have matrix. Well, let's do another question from here. C, matrix A plus B, A plus B plus 2 by 2 identical matrix. See that? A plus B plus 2 by 2 identical matrix. It could be minus 2 by 2 identical matrix. Whichever they give you, just follow the pattern, you will get the answer. A plus B plus 2 by 2 identical matrix. Already we have gotten the answer A plus B. So A plus B plus 2 by 2 identical matrix. You simply put down your answer of A plus B, 5, 6, 4, 5, and then you're adding it to 2 by 2 identical matrix. Remember I told you, put 1 here, and 0, 0. Now, please, 5 plus 1, that is 6. 4 plus 0, that is 4. 6 plus 0, that is 6. 5 plus 1, that is 6. So, correct. Very, very correct. Now, this is A plus 2 by 2 identical matrix. Let's solve another problem. Now you have seen how to add and how to subtract matrix. Let's go to multiplication of matrix. Multiplication of matrix by number. Let's say we have A is equals to 3, 2, 4, 1. And then B, okay. Let's leave it like this. And then let's say find A, 2A. Find B, minus A. Find C, minus 2A. Now, let's solve for the first one. The first one is 2A. 2A is simply the multiplication of all these values by 2. Now let's multiply the values by 2. 2 times 3, that will give me 6. 2 times 4, that will give me 4. 2 times 2, that will give me 4. 2 times 2 is 4. 2 times 4, that will give me 8. 2 times 1, that will give me 2. So this is the value of 2A. 2A means you're multiplying everything in the bracket by 2. Now, what of minus A? Minus A means you're multiplying everything in the bracket with minus 1. Now we have minus 3, minus 4, minus 2, minus 1. Now, for you watching us right now, do the operation of minus 2A and you drop your answer on the comment section. So let's go to the next one. Let's say some articles was sold for a certain price. If the price is increased to 50%, what is the new price? What is the new price? Given that the article is matrix X. So now the certain article was sold for a certain price if the price, a certain price, comma, if the price is increased to 50%. What is the new price? What is the new price? Full stop now. Given that the article is matrix X. And let's say matrix X. Matrix X is equals to, this is 0.1, 0.2, 0.3, 0.4, 0.5, 0.6. Now, what is matrix X? It's a simple thing to do. Look at what you're going to do. What you're going to do is this. Simply find the percentage increase and multiply it by all the matrix we have in the box over there. So let's find the percentage increase. We know that the normal price is 100%. So solution. The normal price is 100%. What's the percentage increase? Now the increment is 50%. So what do? What we're going to do is that 100 plus 50 divide by 100. This is going to give me 150 divide by 100. And that will give me 1.5%. So that I will multiply X, multiply by 1.5%. So 1.5 times by x. This is 0.1, 0.2, 0.3, 0.4, 0.5, 0.6. So what is my new price? The new price, let's call it y. So the new price y will become 1.5 times 0.1. That will give me 0.15. All right. So I have 0.15. So I do the next one. The next one is 1.5 times 0.2. That will give me 0.3. All right. 0.3. Let's do the next one. 1.5 times 0.3. That will give me 0.45. 0.45. All right. Next one. 1.5 times 0.4. That will give me 0.6. Okay. Next one. 1.5 times 1.5 times 0.5. 0.75. All right. Last one. 1.5 times 0.6. 0.9. All right. 0.9.